Hello, everyone. Welcome back to Polycon UK webinars. Today, we have great pleasure of hosting Nina Bobkova from RISE. The title of the presentation is Why Anecdotes? And this is a joint work with Arjada Bardhi, who is also here in the room with us today. Just a reminder, this is a 1 hour presentation. Please unmute yourself if you have any questions. You're welcome to do so. After 1 hour, we'll stop the recording. This talk is recorded, and we might stay for a few minutes if there is any further demand for discussion or questions. The recording is going to be held for a few weeks until we get the permission from our guests today to release it. And just before I leave the floor to Nina, let me remind you that next week, we have Nancy Kian from Northwestern presenting the economic determinants of the Taiwanese sentiments towards reunification with mainland China. Okay, Nina, the floor is yours.
Wonderful. Thanks so much, Max. Thanks so much also to the rest of the organizers for including us in the program. This is a brand new project. We're excited to be talking about this. I'll try monitoring the chat, but if there's any questions, please feel free to interrupt me. And if I'm missing something in the chat, I hope my co-author Arjada can help me out there. So let me dive right in. We start from the observation that persuasion in politics often involves choosing between hard statistics and vivid anecdotes. So in this project, we are going to be asking the question, what's more effective at persuading a skeptical audience? Is it going to be statistics or is it going to be anecdotes? Let me set the stage a little bit and explain to you what I mean with either. So with statistics, what we have in mind, it's something that summarizes data across a variety of different crises, something that aggregates across a population. It describes a general pattern. Okay? So one example of that would be the reform is expected to raise an average tax burden by $400 per year, something like that. That would be an aggregation across the entire electorate or an entire population. An anecdote, on the other hand, is something that is a little bit of a polar opposite. It zooms in into a particular instance, into a particular location, characteristic of a person, or some kind of particular demographic instance, and is more in nature local. So one example would be a targeted case studies of Ohio's 12th district estimates that a 2-child family will save that and that amount per year if the reform passes. Okay, so a case study as opposed to information about the overall population, something very specific, something that is more local in its very nature. Okay, and you can think about this choice between something that is more as an aggregate, as a statistic, or an anecdote arising in a variety of other environments. For example, in the context of a proposed healthcare reform, you might think about how a healthcare increases spending for health insurance overall per year versus for a particular precondition or something like that. In the context of environmental campaigns, how it has an overall impact on an aggregate scale versus on a particular location that is prone to, I don't know, flooding or something like that. So here, I hope you can see my mouse, we've included a couple of headlines from the popular press for you. Anecdotes aren't as harmless as people think they are. Carly Fiorina's anecdotal campaign. Or here's another one, the allure of an anecdote. So it seems that anecdotes have almost a bad rep sometimes in the press. They are viewed with a form of skepticism. After all, they are about one particular instance, not about a general population-wide trend, right? And oftentimes anecdotes seem to speak more to something that is more emotional, something that is more irrational rather than just some rational decision about an aggregate, about something that is aggregate that society should care about. Yeah. Turns out this question, what is more persuasive? Is it statistical evidence? Is it anecdotal evidence? Has a long history, in particular in communication science and in psychology. So we've included here a screenshot from a meta-study by Freiling et al. This is a meta-study of, if I remember correctly, 61 different papers that go exactly at this question of what's more persuasive, what moves the beliefs of people more, anecdotal evidence or statistical evidence. And roughly the summary is, it depends. It depends on the context. There is another more recent paper in economics by Graeber, Roth, and Zimmerman, who ask a similar question: what moves people's beliefs more, if it's statistics or if it's stories? And this paper shows that over the course of a day, it seems that people are forgetting statistics more, beliefs fade more towards the prior over the course of a day for statistical evidence in comparison to stories or anecdotal evidence. Okay? So looking through that literature, if the literature usually finds that anecdotes are more persuasive than statistics, this is usually explained via a kind of a bounded rationality channel of anecdotes are more memorable, they are more vivid, and they incentivize a more emotional reaction to them. So what we are going to do in this paper, we are going to abstract, we are going to ignore all of these bounded rationality explanations, and we're going to ask, if we build a purely rational model without going to emotions or memory, is there ever any reason to persuade a heterogeneous audience with an anecdote as opposed to a statistic? Right? And we see this as kind of a complementary, like the Bayesian account is a kind of a complementary approach to what remains of an anecdote without putting in this emotional or memory channel. And we are going to show when and why anecdotes actually are more effective in persuading our audience or our population than statistics. So for today, we are going to do this in 2 blocks. In the first one, we are going to ask a purely statistical question. How do people learn from either a statistic or an anecdote? How does this updating work, depending on where they are in the population? In the second step, we are going to put all of this inference that we've learned in the first block into a strategic model where we have a policy advocate who's trying to get a population of heterogeneous citizens to approve her policy. And we're going to ask the question, what's better for her to use, the statistic or the anecdote, before we come to a referendum? Okay.
Can I ask a question here just to
Absolutely.
help me triangulate this? So what I have not problem, but statistical, well, anecdotes in this context are also statistics in a way, right? So it's just different form of statistics. So, or another way to put this question is this also a lesson to a scientist who is doing a research? Maybe they shouldn't do an average. Maybe they should just tell the story of this tribe in the Amazon, and that's the evidence.
That's a great question. I'm going to hit at it, I think, throughout the presentation from different angles. So we're taking here in the main model that I'm going to show you, we're taking here a particular stance about what is an anecdote, what is a statistic. You can generalize this notion. You can think of other forms of evidence. For us, I think with what you said, for scientists, it depends on what kind of strategic problem you think they're participating. So what's their purpose of producing this information? But you are right that we could have thought of different other ways of formalizing what is a statistic, what is an anecdote. In the end, it comes back to the following. There is something complex at the background, a policy, something that affects different people differently. There is no way to disclose all of this information immediately to everybody. So we have to find a way to somehow look at some kind of aggregation or some kind of incomplete signal. Statistic will be the average over everybody. Anecdote will be a particular local instance, right? And there's some trade-off between the two, how people will learn and how this is going to play out in our strategic environment. But you're right, that I hopefully this will be useful for others as well. Does this answer your question, Max? Okay, perfect. Now, let me move on and give you kind of a preview of the results that are coming. So, sorry, now I see all of the videos as opposed to my own slides. Let me change this again. All right, so here's the preview of the results. There's going to exist a unique threshold on the consensus or the voting rule that our population is going to face, such that the following will be true. If we require narrow consensus to implement the policy, then the anecdote is going to be strictly optimal for the policy advocate to disclose. Narrow consensus, anecdote. If we require a broad consensus, if the threshold is sufficiently high if the voting rule is sufficiently high, then the statistics is going to be the optimal form of evidence for the policy advocate to disclose. Okay. And to preempt a little bit of what is driving this dichotomy, there are going to be two competing forces. The statistic per se, since it's going to average over everybody, is going to generate a stronger response, stronger support across the entire citizenry, which is going to favor the statistic. On the other hand, the anecdote, because it's about a local instance, about basically a point, is going to have more variability in terms of outcome. So more favorable realizations are going to happen more with the anecdote. And which of the two effects takes the lead will depend on how much consensus we require to implement the policy. So basically, this is what I'm going to spend the remaining 40 to 50 minutes explaining to you why this slide is true. Okay. This is it for the introduction. Unless there are any questions, I'm going to start with the model. Okay. So we have one policy advocate, and there is a unit mass of citizen indexed by I. You can think about this, the population here in this figure is sitting between 0 and 1. There is this policy with uncertain and heterogeneous outcomes across the citizens. We capture it by the outcome mapping F. Okay? So if you are citizen here, 0.2 or whatever, your policy outcome will be whatever you see here on the yellow outcome F. Now, nobody knows the outcomes across citizens to begin with. Neither the policy advocate nor the citizens, but they all share a prior about the family from which that F is drawn. So now I'm going to impose a couple of assumptions on the process from which F is drawn. Our outcome mapping is Gaussian. So it's a Gaussian process with some mean mu and covariance sigma. And it has what we believe are quite intuitive properties. Take any two people, I and J. How correlated are their policy outcomes is going to depend only on how far away from each other they are, not in addition on their absolute position. So we have a distance-based correlation between people's policy outcomes, which is captured for us by this function tau that depends only on distance between people, just to reiterate, not on their absolute positions. Okay. We have positive correlation. Whenever we have a good news for one citizen, that's also good news for the others. Correlation is decreasing in distance. The closer together two people are, the stronger correlated they are. The further away they are, the less correlated they are. Correlation is weakly convex. So correlation decreases the strongest on short distances. And the variance of every single person is normalized to 1. Final assumption, the expected outcomes are constant across citizens. So ex ante, everybody expects the same outcome from the policy. Okay. So maybe let me give you one example of a correlation structure. Sorry.
Nina, I'm sorry.
Yes.
So can I just think about this like a realization of a Brownian motion without a drift? Is that how I...
Yes, so the reason we don't have a Brownian motion in here is because this would depend on the further out you are, the more variable you become. So then the correlation between two people will not be the same depending on where they are located on 0, 1, right? Depending on where you start. If we have time at the end, I can tell you what happens with the Brownian at the end. We have the results as well. For now, let's talk about distance-based correlation structures, which would rule that out. And one example of this, if you want something concrete to think about, Arda, think about the Ornstein-Uhlenbeck correlation that I've actually used with Arjada in a different paper. So this would be the distance between two people who are a distance d away from each other, e to the power of minus d divided by l, just the distance between them, not their absolute position. And L going to 0 would be as we approach independence. L going to infinity would be as we approach perfect correlation. So here's just one example of how this correlation structure would look like. Here's the distance on the x-axis. Here's the strength of correlation, and depending on how far away from each other they are. Okay. So maybe let me just quickly flag two things about the model is that ex ante, all my citizens face identical uncertainty. Their policy outcomes are Gaussian with the same mu and the same variance. But of course, how they're going to learn from different forms of evidence is not going to be the same. It's going to depend where they are and how far away the information is from them. No? And we think about this x-axis as a form of demographic similarity between citizens. All right, now let me talk about these two types of evidence that we're going to analyze. What is a statistic? What is an anecdote? Statistic, like we've been hinting in the introduction, statistic is just the average policy outcome across the citizenry. It's just a number that is the average over the policy of everybody. Since every policy outcome is Gaussian, so will be the statistic. Okay? And let me just flag already here that since the statistic averages over everybody, it will be less variable than every individual person's policy outcome. So sigma for us denotes the variance of a statistic. The statistic aggregates or smooths out over everybody, so the statistics variance will be lower than every single person's. Okay. Now that we understand what a statistic is, let's go to the anecdote. For the anecdote, our policy advocate gets to choose which citizen to feature in the anecdote, who is the anecdotal citizen. And then for that citizen, the policy outcome will be generated. So here our policy advocate choose this person, IA, and then the policy outcome of that citizen, which is the anecdote in this case that is revealed, is this point right here, how the policy is going to affect that person, which is clearly also Gaussian because this every person's policy outcome is.
Can I ask a question?
Absolutely.
So this assumption that the mu is the same for everyone,
Yes.
and also, I guess, the policy advocate as well, right? They don't have additional information, private information that they have. So that means that it doesn't matter which eye you choose. You don't know which eye to choose ex ante. Is that right? You could imagine a setting where the policymaker knows that certain eyes are more likely to be higher realizations than others, whereas you don't assume that. So I will pick just a random eye of some kind. Is that I don't know. You can probably pick more than one, right? But I don't know.
Yeah, there are a lot of questions here. Let me start from the following. So I agree. In our model, the policy advocate and the citizens, they all have the same prior. It's not that the policy advocate is more informed and her choice of what to pick will convey additional information. Now, I can tell you later on, depending how much time we have, what happens if we have not the same, basically expected net outcomes from the policy versus the status quo. For now, there's already quite a lot of heterogeneity built into the absolute positions of where people are. What else did I want to say? Exactly. So it will matter which anecdote you pick. You are right that ex ante all the anecdotes have the same distribution, but it's not true that all the citizens are going to learn in exactly the same way from the anecdotes. It will depend on where they are. I'm going to show you this in the inference section. All right. So the position will matter and the policy advocate will have a particular anecdote that she will want to disclose.
So it matters because you have an interval. If you had the whole real line, it probably would be different. Something like that.
Depends on the distribution of citizens across the real line. But once again, based on the distance, they will update differently. So I think you're anticipating where I'm going with that.
Yeah.
Thanks, Francesca.
Okay.
If I may follow up, speaking of the intervals, so here you reveal 1 point, which is zero measure, and I'm not sure like how variable is the line, kind of, does it go like back and forth a lot? So kind of why single point, but not say a small interval? Does it matter for anything?
Excellent. It matters for the inference quite dramatically. And I think it goes back to, a point that Max asked a while back. We took here really a stance. So what I'm showing here in the baseline model is the most extreme case. The statistic is the average over everybody, like Lebesgue over everybody, the entire interval. While an anecdote is not, it's a direct measure at a particular point, right? You could think of statistics not being over the entire interval, but something that is a more regional statistic. You can think about including more than one person in the anecdote. both of these extensions we have in the paper. I am afraid, given how I'm doing on time, that I will not have time to talk about that. What I think I want you to take away, if you want to keep this in the back of your head, the two effects that I'm describing, the inference, many things will extend, and many of the qualitative results will extend that too. So these effects that I'm building up towards that I mentioned in introduction, wildcard effect, umbrella effect, that will be also present with this more intermediate notions of a statistic and an anecdote, Konstantin, if this is helpful. All right.
Yeah, my main concern was kind of mathematical. So it's kind of, does zero measure set specifically matters here? But that's
So
it.
we have if your worry is about being well defined, this is assumptions we baked into the correlation structure to make sure that we have a well defined object, like the on the tau functions, the differentiability and things like that. So that we
Can I jump in maybe for a moment? Just to kind of, because Nina will not talk about this, but this is actually something we're very excited about. So you can think of evidence types that we're modeling here as being part of a larger class of linear functionals of this mapping F. And you can think of the anecdote as putting the Dirac measure on the anecdote citizens. The statistic is putting the Lebesgue measure on the entire interval, right? And then we generalize things to any measure that you might want to put on subsets of individuals. So the short answer is that as long as you're looking at a point or a small interval around the point, it will matter for how people update beliefs, but it will not matter for the optimality of evidence. Sorry.
Thanks, Arjada. All right. And like you said, unfortunately, I won't have time to talk in detail about generalizing this, but hopefully we'll have the paper ready in a few weeks with all of that in there. All right. Let me then summarize. So we know what a statistic is, average, in the baseline model. We know what an anecdote is. Like I mentioned before, the policy advocate commits to the evidence type before learning its realization. So there is no cherry picking going on. This is a model of commitment to anecdote or to statistic. Final slide of the model, the decisions. So the citizens are going to collectively decide whether or not to implement the policy. Each citizen is going to vote in favor or against the policy based on their update. And the policy is going to be implemented if we get at least a mass queue of citizens to vote in favor. Otherwise, we go with the status quo. Finally, the payoffs. The payoff for the policy advocate is quite simple. She wants the policy to be implemented. If she gets the policy, she gets a payoff of 1 for the sake of normalization. If she doesn't get the policy, she gets a payoff of 0. The citizens get their policy outcome if the policy is implemented, and they get a payoff of 0 if we go with the status quo. One thing I want to flag at this point is that we assume that all citizens are ex ante against the policy. So their status quo payoff is higher than their expected payoff from the policy. If this wouldn't be the case, we would not have the most exciting problem. Imagine everybody today is already in favor of the policy. Why disclose any information? Just don't disclose anything and all the citizens are going to vote in favor. Okay, so that's why we assume that all citizens today are against the policy, with 0 larger than the expected outcome of their policy. Okay. Given how we are doing on time, let me not talk too much about the discussion of the model. We've already discussed that we can generalize the policy, the statistics and the anecdotes quite a bit, and go into inference. Let me pause here for a second in case there are any questions.
Just very quickly, I must have missed it. In terms of prior beliefs, what is there? There's absolutely just the mu is commonly known. There's no prior on the Fs. No, what are you assuming there?
So for now, everybody is completely homogeneous in terms of what is their expected policy outcomes. It's just an expectation mu, same for every person.
Right, but they only have expectations about the mean. They don't have expectations about the F as such or any other statistic regarding the F.
Let me quickly go back to the slide on the correlation, just to make sure that I understand your question correctly. So this outcome, these outcomes across all the citizens, everybody knows from what family it's drawn. everybody agrees that this is the assumptions on the correlation structure, the world in which we live. Everybody has the same expected means. And the policy advocate, ex ante, as well as the citizen, all have the same initial uncertainty. Does this answer it, Francesco? Am I missing a point?
So beliefs are distributions over unknowns.
Gotcha.
So I will have a belief about my possible outcome and everybody else's.
Yes,
right?
exactly. Your payoff only cares about your own, though.
Yeah, I only care, but it matters whether and also because the designer is also part of this, they also have beliefs and they're common. That's why it matters. But so we're assuming that there is a background, a belief about this, and you're imposing restrictions on what these beliefs have to satisfy. But you are assuming that there are beliefs on this. It's not that. So they have beliefs about the variance of VF, for example. It's just that you're not putting restrictions on them. Is that accurate?
Bayesian. I think so.
Yeah.
If I understood you correctly, everything is going to be perfectly Bayesian.
Yeah.
All beliefs are Gaussian in this world, which is going to make a big deal for projectability. We don't have to for some results, but yes. And this is a purely Bayesian environment. So we have well-specified beliefs. We have a well-specified correlation structure.
Okay, I'm not sure I still get it, but I'm sure I'll figure it out.
But let me ask a related question very quick. So the evidence is just revealing the realized mean or not. Is there any value for revealing the realized variance? Or
yes, nice. So we are talking, maybe I should not have skipped that slide. So this is not an exercise in unrestricted information design.
Yes.
We give the policy advocate these two very empirically relevant, but still restrictive notions of revealing information, either a statistic or an anecdote. The policy advocate could potentially, in an unrestricted world, design different signals involving the higher moments, like you suggested, or something else. We do not look at this. So our model is really the comparison between statistic, anecdotes, or some kind of other linear functionals that Arjada mentioned.
okay, thank you.
All right. Now let me come to the first block of the analysis, where I'm just going to talk to you about how to learn from different types of evidence. So let's start with the anecdote. Let's assume the policy advocate chose that person, IA, and this was the policy outcome that was observed by everybody. You're citizen J. How are you going to learn from that? So everything is Gaussian, so you are going to, your expected policy outcome, given the anecdote that you have seen, will start from the mean, will update in the direction of the anecdote, but how strongly you update will depend on how far away you are from the anecdote. This is a weight that we denote by gamma for the anecdote for you as citizen J. This weight will have a couple of nice properties. First of all, if you happen to be the anecdotal citizen, you update all the way. You learned your policy outcome. There is no uncertainty left. So your weight will be 1. The further you are from the anecdote, the less you update, right? Because the correlation strength decreases with distance. This comes back to Francesco's point about it does matter which anecdote you pick and how far away from it you are in order to update. And coming back to Arda's questions about Brownian without a drift, it's symmetric to both sides because we have a distance-based correlation structure. So the weight is symmetric from the anecdote. Let me show you one figure that I think will make it more intuitive. So in this example, a policy advocate chose that anecdote, that citizen IA. It happened to be the case that the anecdote was, let's say, 1.5. How does everybody update will be given by the green line. So the anecdotal citizen updates the stronger with a weight of 1. The further away from the anecdote you are, the less you update. It's convex because correlation, our distance-based correlation is convex. And because of positive correlation, if it's good news for one person, it's good news for everybody. So everybody keeps updating above the mean, which was mu, just to remind you. Okay. So this is how the updates look like from an anecdote. Just to anticipate where we are going with this, if the status quo payoff is V0 as plotted here. Who would vote for the policy in this environment? It would be those people around here who updated and had a sufficiently high update from the policy in comparison to the status quo. Okay, so that's as simple as the updates look like. This is who says yes based on the anecdote. Okay.
Just a quick question. So apologies if I didn't understand very well, but that means that an anecdote never has a cost politically. You never learn that, there's this thing that's good for someone who's really different to me. And so actually they're too different. It's just not for me.
I think what you're
everybody
asking me to
updates
is- So that's
positively.
okay, Valeria, if I understand correctly, so what you're asking me about is, do we allow for negative correlation? If it's good news for you
Yeah.
because you're at the other location, it must be bad news for you
Yes.
because it's zero sum. Yeah, no, we are ruling that out by the correlation structure assumption that we have positive correlation.
Thanks.
Thanks. So let's do the same exercise for the statistic. How do people update from the statistic that is the average? It's still, the update still is Gaussian, it looks similar. We start from the prior. We update in the direction of the statistic V. The weight now looks a little bit more complicated than before. What this is basically covariance divided by variance. So in the numerator, we have how you as a citizen J, how relatively representative are you vis-a-vis the whole population? In the denominator, we have the overall variance of the statistic. That is essentially how representative a randomly drawn citizen is from the population. And let me show you, before I show you the properties of this updating weight in a figure and basically hand wave my way through how updating works from the statistic. This figure you've seen before. This is the green line, the update from the anecdote. What we're plotting here in orange is the update from a statistic that has exactly the same realization as the anecdote before, 1.5. So you're citizen J. How do you update from the aggregate, from the statistic over everybody? Imagine you're a citizen that is relatively close to the periphery. You don't have that many neighbors essentially to your left, right? There's not as many neighbors of you represented in the overall statistic. So it's clear that you don't update all the way to, let's say, the statistic that would be 1.5 here. So the more peripheral guys have to update below the whatever the statistic was. But then, by a law of iterated expectation, if we have some people updating to below the realization of the statistic, somebody needs to have kind of an overreaction. Somebody needs to think, oh, if on average the statistic is the outcome is 1.5, mine must be even higher. So we get this overreaction at the center of the society. There are people here who update even stronger than the realization of the statistic. Okay, let me formalize this. So this updating weight, how strongly you update in favor of the statistic, it's symmetric around the center of around the median citizen. It's clearly monotonic. The further out you are, the less representative you are, the lower your updating weight. It's strictly concave. That turned out to be quite a general property that is true not just for convex correlation structures. And we get this overreaction in the center of the society. We get this overly enthusiastic median citizen and people around him who even update stronger than the statistic would suggest. Okay. So in this example, who votes in favor of the policy after seeing the statistic realization with the same realization as the anecdote? Well, everybody who updated to a value above the outside option, above the status quo, which would be, in this particular plot, a larger interval. And by the way, let me flag, the reason why I'm only plotting here in this figure the realizations above the mean, if we ever have a statistic or an anecdote that ends up below the mean, that means that it's bad news for everybody. Coming back to Valeria's question, it's bad news for everybody because of positive correlation. So nobody ever votes for the policy. Okay, so these pictures would essentially flip. Okay, so now we know exactly how the updates work from the anecdote, and we have seen how the updates work from the statistic. I'm going to now use that all in the strategic problem and tell you how a policy advocate will use either form of evidence to get the highest possible probability of approval of the policy. But let me pause here again for a second in case you have any questions.
I have just a clarification question because you focus on inference, but there's also a voting decision.
Yes.
And voting is obvious because there are just two options and people choose what's dominant for them.
We have a continuum of people. So if you're asking, nobody is pivotal, but we assume that people vote as if they're pivotal, and then they have clearly their vote for whatever alternative gives them the higher expected utility. That's a good question. I should probably be saying this in the model. Okay, thanks. All right, let's now talk, coming back to voting, into the strategic choice of the policy advocate, what information to choose. One thing I've hopefully convinced you is that whenever we get people voting in favor of the policy, this is always going to be around some form of a central citizen, whoever that is. In the example of the anecdote, the person who updates the most is exactly the anecdotal citizen, and those who approve will always be those around the anecdotal citizen who have a sufficiently high expected value of the policy after updating. In the case of the statistic, the person who updates the strongest is exactly the median, the central citizen, and those who approve the policy are always going to be an island around him. So with this understanding, we can ask a question of, well, coming back to the question, who should be the anecdotal citizen? What's the best possible anecdotal citizen for the policy advocate? For the policy advocate, it turns out the best possible citizen is exactly the median citizen. It's the guy sitting in the center of the population. And I think given what we've developed, it's quite intuitive. Imagine you were to pick an anecdotal citizen that is extremely close to the periphery, very close to one. To zero, the way that I'm showing it here. For a realization that is relatively high, you get a bunch of people voting in favor of the policy. But unfortunately, in a way that this is plotted right here, you ran out of citizens to your left. If there would be more people, because they are so close, they would have voted for it. But unfortunately, you reach the end of the population, right? But by putting the anecdote in the center, at least you can make sure that those guys voting for and against are always basically the same distance. You're not running out of people to either side. So it's without loss for the policy advocate to pick the median citizen. It's not uniquely optimal necessarily. As long as you don't run out of people to the right and to the left in the pivotal case, it doesn't matter. But using the median citizen as the anecdotal citizen is without loss. Okay. So from now on, we will assume that.
Nina, can I ask
Absolutely.
a question? I would have thought that, the politician would pick the anecdote that is better to use, in the sense that, you might collect some data. I can see the anecdote as data, and maybe, the median guy, the anecdote is not positive because it's below V0, but there are some other points that you have collected. You don't need to collect everything, right? But that will be above the status quo value. And so there's some cherry picking that I could think in anecdotes that in statistics, it's not present because by definition, you have to average across all.
That's an excellent point. So I think it depends on what kind of environment we think we live in. So in the language you just use, collecting this information, if those people knew precisely their policy outcome and it would be just some random questionnaire going around, we wouldn't have an information persuasion problem. If people already know what their policy outcome is, they'll vote. We don't have a choice of influencing them. So what we have in mind is some kind of policy, something that is not obvious how it's going to affect us, will take time to learn. And the question of the policy advocate is, what kind of report to commission? Do you send out a report for an expert to basically trying to figure out overall the effect? Or something that is more local and run a case study? But at the moment in which you commission the report, you don't know the outcome. There are other environments, and I agree with you, in which cherry picking might be a first order consideration. Then the people, the way that they update, will have to understand that, well, you learned about this person right here, so that probably means that every other outcome is lower. And that potentially leads to this unraveling force, right? So I think it depends what kind of world you think we live in and what kind of policy we are considering. This right now, the model that I'm showing you is going towards, this is an uncertain world. It takes time for policy outcomes to be determined, and you have to make the decision before you know all the way the outcome that is going to be the result of this long-term study, if that's helpful. Thank you, Ines. All right. So what this means for us is that, just to remind you, we realized the anecdote is without loss to be picked at the center, at the median citizen. And now the problem reduced dramatically. We know who are the pivotal citizens for both types of evidence. Not only that, we know that they are the same for both types of evidence. Let's assume that we would have a simple majority, for example, by which we are selecting people. This is for the anecdote. So then we would have to guarantee the support of half the quota to the left and half the quota to the right of the median citizen. In this plot, it wasn't enough. The outside option was too high. The policy wouldn't have been elected. On the right, we have the statistic that had such a high update that the policy would have been implemented because my pivotal citizens are already convinced that it's better than the status quo. Okay, so this dramatically reduced the complexity of the persuasion problem. It also shows us that now that we know who the pivotal citizens are, and we know where the median, so basically what anecdote is optimal, it turns out that this updating weight, how every citizen updates, how strongly they update from each form of evidence, this weight is stronger for the statistic than for the anecdote for every single person in the population. So if you go back, that means that for this figure, we have a higher expected value from the policy for the same realization of the statistic than for the anecdote for every single person. The statistic has a wider reach across the population. Everybody responds stronger to it. We even have this overreaction in the center of the society. Okay. Now, what's the probability of approving the policy? That's what the policy advocate wants to maximize. Everything is Gaussian, so it reduces to this beautiful form here. The probability that the policy passes is, this is, just to remind you, the expected policy outcome minus the status quo. And in the denominator, we have the updating weight times the variance of the evidence form. This is essentially the correlation between the pivotal citizen and whatever evidence we present her with. And because every citizen ex ante is against the policy, we want to provide the pivotal citizens with as much information as possible. We want to correlate their policy outcome with whatever evidence we provide. And the question is, what's more correlated with the pivotal citizens' policy outcome? Is it going to be the statistic or the anecdote? And this is going to determine what policy is going to be, what evidence is going to be optimal for the policy advocate to disclose. Summarizing the two forces that determine what evidence is best. You've seen the statistic leads to higher updating, per realization, per positive realization for every single citizen. That's the umbrella effect. It reaches wider through the population. The downside, though, this is the reason the statistic is not obviously better always. The downside is the statistic is not as variable as the anecdote. It smooths out over everybody. Imagine we go towards independence, then the statistic would hardly move at all, while every anecdote has a variance of 1. So this is the wildcard effect. The anecdote has higher variance, and that favors the anecdote. And which of the two forces is dominating depends on where the pivotal citizens are. Let me formalize now this main result that I mentioned in the introduction. So we have this unique threshold on our voting rule, Q bar. Whenever we need narrow consensus, whenever we need a smaller fraction of the population to approve the policy, anecdote is going to be strictly optimal. Whenever we need broad consensus across the population, statistic is going to be strictly optimal. Let me give you the intuition for this result with two extreme cases. Let's assume that we just have a quota going to 0. We essentially need just a sliver of the population to approve the policy. Who is the pivotal citizen in this environment? right? So we just essentially need just a sliver around the median to approve the policy. The pivotal citizens basically approach the median citizens from both sides. What was the question? What's more strongly correlated with a pivotal citizen? Is it going to be the average over everybody, or the outcome at the median citizen itself, which is essentially the pivotal citizens? Okay? So with other words, what I'm asking, what's more correlated? Is it your outcome with your outcome? Is it your outcome yourself or the average over everybody? And clearly the answer is going to be your own outcome. That's as correlated as you can get. Okay? So clearly the anecdote will be optimal for a sufficiently narrow consensus, especially as the quota goes to 0. What about the other extreme? What if we need unanimity? What if we need the entire population to approve the policy? Who are the pivotal citizens? The pivotal citizens go all the way to the periphery of the society, 0 and 1. Okay? Imagine, just for the sake of intuition, that we have a really convex covariance. You go a little bit away from you and then you're relatively uncorrelated with whoever is there. Imagine you are citizen 0. What are you more correlated with? Are you more correlated with the guy who is half a population's length away from you, the median citizen? Or the average over everybody that also includes your immediate neighbors and the whole interval around you? Right? This is beautiful Jensen's inequality at play. You're going to be more correlated with the average than with the guy exactly at the center. And then the rest of the result that I've shown you is to show that there exists a unique crossing point for a quota, but so that for sufficiently narrow consensus, anecdote is optimal because your pivotal citizens are essentially close enough together for the wildcard effect to dominate. While for sufficiently broad consensus, you need to persuade a wide range of the population. The umbrella effect makes sure that the statistic has a wider reach, so that's the dominating force. Okay, so that's the heart, really the heart of the paper. I will briefly now talk about comparative statistics and other extensions, but let me pause here for a second in case there are once again any questions. Okay. And I'm seeing that I have missed a couple of questions in the chat. I hope Arjada has taken them. If not, feel free to unmute yourself and ask me. Okay. So here's one plot. You might be thinking, what happens as correlation becomes more or less strong? What happens to this threshold and how does everything pay out? So this is an exercise for a particular correlation structure. This is for the Ornstein-Uhlenbeck correlation that I have mentioned in the beginning. Let me just remind you that Ornstein-Uhlenbeck was this, the correlation between two people a distance d away from each other was e to the minus of d divided by L. L going to 0 would be independence, and going to infinity would be perfect correlation. Everything we have done so far was give me a correlation structure, so pick any L you want. We have proven that there exists a unique threshold, you see this on the y-axis, below which anecdote is better, above which statistic is better for the policy advocate. Here, this plot shows you also what happens as we vary correlation. First of all, for L going to 0, both we approach independence. So both the statistic and the anecdote become basically uninformative, but at least the statistic still has your immediate neighbor surrounding it. So on the margin, the statistic becomes globally better. So we have, as L goes to infinity, our threshold quota goes to 0. So we want to use the statistic almost always. On the other hand, as L goes to correlation, we want to use the anecdote in more and more cases. And here is what it goes to in the limit that you see in the proposition. Okay. Given the time, how much time do I have? What do I want to do? We had a couple of questions throughout the talk about how to generalize the evidence structure, how to think about including more than one citizen in the anecdote, or a more local, basically a regional statistic as opposed to including the overall population. Let me maybe start there. So let's talk about what happens if the anecdote is not just about one single citizen, but it includes several other citizens as well. So now we are disclosing the average of the citizens' outcome. We still have a zero measure of citizens in the anecdote. We still have this nice comparison between a number for the statistic and a number for the end citizen anecdote. Now, the only difference is that the anecdote contains potentially, depending on what the policymaker decides, more than one citizen's outcome. Both are linear combinations, and as we split out the citizens equally, the anecdote in the limit approaches the statistic, so we have a nice smooth transition here as well. So let's see how the anecdote and how inference would work when we include two citizens in the anecdote. Before, if that was the chosen person, that was the anecdote that was disclosed. Now, let's assume that we allow the policy advocate to include two people in the anecdote. This was this person right here, this person right here. So the anecdote will just be the average over the two of them, which is denoted here by this yellow dotted line. Okay. How do people learn now from this two-citizen anecdote? Inference is similar, a little bit more complex, but similar to before. If you are the anecdotal citizen, you update all the way. The further away you are from each anecdote to the boundary, the less you update. And in the interior, of course, you draw inference from both of those anecdotes. So now, one qualitative difference is that now the support for the policy might be no longer one interval, but might consist of two disconnected islands. Imagine, for example, that the status quo payoff would be right here where hopefully you see my mouse. In this case, we would have those two disconnected islands of support. So then the question becomes, what's the optimal choice of an anecdote? Which people do you include? How far away from each other and so forth you are? We show for Ornstein-Umberg correlation that the optimal anecdote has exactly 3 pivotal citizens, those at the outside, this, as you've seen before. And this guy in the middle is exactly pivotal as well in the optimal two-citizen anecdote. Ignore the picture on the left. I don't want to go over it. Just look at the picture on the right. So for this two-citizen anecdote, the picture on the right you've seen before. This was this blue line. Below it, the anecdote was optimal. Above it, the statistic was optimal. And below it, the anecdote that was optimal was for one citizen. The difference is that now we have this red area in this picture, and that shows you the area in which the two-citizen anecdote, the one that we were just describing, is better than the statistic. And we can see here that for sufficiently strong correlation, it might be that the anecdote including two citizens is globally better than the statistic. Okay, for any quota, for sufficiently strong correlation, the two citizens anecdote is dominating the statistic here. So as we probably would have expected, as we include more and more people in the statistic, in the anecdote, the interval in which the anecdote becomes better increases.
Can I ask a question about this thing? Because so in a way, exactly the example that actually I have two questions, but the first one is in exactly the example you showed us, you showed this kind of circus tent shape that derives from the two anecdotes. But if I was thinking about this, I would say, well, okay, I am closer to the one on the left, so okay, that went well. But actually, it went well for the other one on the right. And these are very far away from each other. So maybe actually this is a good policy because it is working well for different, for very disconnected agents. So, I mean, I don't know whether this is already in the picture that you've drawn, but it seems to me that, in fact, qualitatively, not quantitatively, it should be flatter around the peaks. It actually, there should be an effect that the farther away the anecdotes are, conditional on them turning out to be good, the better it is for figuring out what the policy is. Now, I maybe there's something in the model that doesn't allow for this, but my natural intuition is that that's what should happen there, right? In a way, when you go away from one anecdote to multiple anecdote, the question of where you put the anecdotes starts to get really interesting, I think, right? Because with one, you got to go to the medium. With multiple, maybe you want to go to the extremes, actually, in a way. I mean, maybe ex ante it's not optimal, but in ex post maybe it is, right? So I don't know.
I agree. So I think what you're describing, if I understood you correctly, is to some extent already in the figure. You have two people for whom the outcome is one as opposed to one. You end up in the middle. So the updates here, if you're in the interior, ends up being higher. Well, you're in between two guys, and for them on average, it's good news. What this goes to is, I've been describing this umbrella effect. The statistic has uniformly wider reach and the wildcard effect. But here we've included one more citizen in the anecdote, so we reach wider. What you've not mentioned, Francesco, and I have not either, is by including an additional person, what that means is my variance of the anecdote is no longer as high. I have two people now, right? So if they would be very, very close to each other, their variance would be close to one citizen's outcome. But the further out they are, the lower the variance becomes, right? Because you're smoothing out. And it turns out that if you pick two people really extreme from each other, if I remember correctly, the variance can be even lower than that of the statistic. So you're balancing two effects here. The fourth that you describe is there, how far the anecdote reaches now that you include more people. But at the same time, you pay the price of decreasing overall variability. And don't forget, all of your people ex ante, they don't want the policy. So you want to convince them, provide as much information as possible to push them above the status quo payoff. So both of these things matter. Now, what the optimal distance between them is, that depends. And that's the figure that I didn't have time to show you. And I think given that I have like 3 minutes, I won't. But that depends on the strength of correlation, on the quota that we need, and how broad this pivotal mass of citizens is that we need to persuade. So I think your intuition is spot on.
Can I ask a question about
Sorry,
the?
can I ask? Maybe we should let Nina finish within the allotted time, and then we can stay after the talk and continue with for as long as there's willingness. Is that okay?
That sounds great as
Okay.
well. Let me just wrap
Yeah.
up. I don't think I'm going to show you another extension, so let me just tell you a little bit. I mean, I've mentioned. So with the time that I had, I showed you how to generalize to more than one citizen within the anecdote. But we can also generalize the statistics to not go over the entire population, but just be regional. And there are, like Arjada mentioned before, other versions of evidence, just the linear function of different measures over our unit interval, depending on what you have in mind. Heterogeneous expected payoffs, would have loved to tell you about that. It looks like given the time, you'll have to read the paper or to stay on the call afterwards to discuss this. Let me just wrap up. So we asked the question, what's more effective at persuading our heterogeneous audience? And we've learned that if we need really broad consensus and we need this big support of the population with the pivotal guys really far away from each other, the statistic really takes the lead. It reaches further, it has this umbrella effect, and is more effective at persuading a heterogeneous audience. For a sufficiently narrow consensus, on the other hand, the anecdote takes the lead. It doesn't give us this overreaction of every citizen to the positive information, but it has this wildcard effect. It's more variable. It's more likely to give extreme outcomes that are favorable to the policy advocate. And it's more effective for a homogeneous or narrow audience. Let me just repeat the point that we don't see this as competing, but just as complementary insights to the usual way that the literature handles anecdotes. It would be really interesting to see how the Bayesian framework interacts with this insight of people remember anecdotes more. They are introducing them to have strong emotions, and this is why the beliefs shift more. So we provided a Bayesian benchmark, I think, and it would be interesting to see these two things together. And we hope that there are other questions about information, like similar to Inez's question on cherry picking and so forth, that this framework hopefully will prove useful to answer in the future. So let me stop right here and thank you all.
Excellent. Thank you very much. This was super, super exciting. To everyone else, see you next week, and we can turn the recording off.